So could everyone please be seated? Thank you very much. And go ahead and start eating. It's delicious. You'll like it. So we're just about ready to start. If you could please sit. Thank you. Okay, are you ready? We're ready to roll it out if you are. So good afternoon. Thank you so much for coming. Thank you for your time and thank you for your interest. We are so grateful that you're here. Thank you. So I'm Marcia Lewis, and it is my pleasure to be the president of ARCS Foundation Seattle. Wow, and it's my pleasure to have you in the audience too. Thank you. So may I begin by expressing my gratitude to my fellow ARCS members whose efforts have brought us here to lunch today. Through your dedication, you create the ARCS Foundation pipeline to the economic engine that builds Seattle's biotech community and influences the world. Thank you for all you do. So could I ask you all to imagine sitting with me in Washington State University's Beasley Coliseum on August 26th, 2015. You can smell and you can see the smoke from the fires that are plaguing the area. It's hot. The Coliseum is full. The crowd is curiously quiet because we are there to participate in Dr. Elson Floyd's memorial service. Imagine with me, if you will, wave after wave of maroon and gray t-shirts. Those are the teams that are coming into the Coliseum one by one. They're marching in formation to join the nearly capacity crowd of 11,000 people. Representatives from ARCS Foundation are there to honor Dr. Floyd, and you are there with us by virtue of your participation with ARCS Foundation. Along with the teams, his colleagues, and students, ARCS Foundation embraced this man because of the warmth with which he wrapped us. Dr. Floyd passed away during his presidency in June, but not before leaving his mark of, among other things, tripling research grants. ARCS Foundation experienced another great loss this past year. Retired University of Washington President William Gerberding, also beloved and an inspirational leader, passed away in December. He navigated through the tumultuous 1980s, and the result was that 4 Nobel Prizes were awarded to the faculty. To honor these inspirational leaders, the Seattle chapter will name fellowships in memory of Dr. Gerberding, whose wife, Ruth, is an ARCS Foundation member, and in memory of Dr. Floyd. Thank you. Fortunately, Dr. Floyd and Dr. Gerberding, like all good mentors, left some visionary leaders in place, and we are honored to have with us many of them today. So will you please stand when I call your name? Acting President of the University of Washington, Dr. Annemarie Kause. And from the University of Washington, Graduate School Dean Dr. David Eaton. There you are. And from WSU, Dr. William Andrzejewski, Dean of the Graduate School. Dr. John Gardner, Vice President of University Advancement and CEO of the WSU Foundation. Connie Kravis, who is the University of Washington Foundation CEO. Connie. And Dr. Erica Austin, who's the interim provost at WSU. Many thanks to the luncheon co-chairs, Sarah Dunham-Watts and April Pride Allison. Please stand and take a big bow. There they are. They strategized all year long to bring you this exceptional program. Thanks to our remarkable Director of Operations, Jennifer Huck Arnold, and our development consultant, Harshika Kara. I think they're probably out in the hall, but thanks, guys. And to our indispensable liaisons from the UW, Jan Harrison, Assistant Director of Advancement. She's back in the booth. And from WSU, Joe Merrill, WSU Foundation Director of Stewardship. Thank you for all you do for us. Many thanks also to Cheryl Hadley and Jenny Wyatt. Please stand because you need to take credit for those beautiful pieces of material that are on your chairs. They're the co-VPs of communications at ARCS Foundation, and they did a great job. Jenny and Cheryl, wherever you are, please stand. So we're hoping that you will pass those materials along to a friend you think might value the opportunity to become acquainted with ARCS Foundation. That's what they're for. Take them with you and pass them along. On July 24th, when the Museum of Flight announced the launch of Boeing Academy for STEM Learning, Ray Connor, Chief Executive, said, 45,000 future jobs in the region requiring STEM credentials could go unfulfilled because we don't have people qualified to fill them. Happily, we in this room are positioned to fill that need. Giving fellowships to the UW and WSU in the STEM area, which, in case you don't know it, I'll review with you, is science, technology, engineering, and math, is exactly what we do. And we are grateful that many corporations partner with us. Our corporate sponsors have ensured that every dollar today will support ARCS Foundation's mission. The sponsors may be familiar to you because they represent the best of Seattle charitable giving. And they're going to be up on the screen. There they are: Ram Mounts, Boeing, Fred Hutch, Goldman Sachs, Microsoft, Physio-Control, Washington Research Foundation, Wyman Youth Trust, Alaska Airlines, USI Kibble Prentice, Seattle Children's, Stratos Group, UW Medicine, Wells Fargo, Nancy Clan Outh, Bill and Jill Ruckelshaus, David and Catherine Skinner, and thank you to all of you for your corporate support. We are truly privileged to be among your recipients. ARCS Foundation lives this year's luncheon theme, which is on your materials: discover, deliver, impact. Aren't those three compelling words? We are so fortunate to be part of an organization that promises this destiny. Who are these fellows you're here to support? They are 155 strong PhD candidates who receive $907,500 from ARCS Foundation this year. You may not know that when Seattle chapter of ARCS Foundation was established 37 years ago, the mission was to help ignite America's competition in science and technology. The testament to a mission is whether it meets the test of time. Today, that mission remains relevant as it was in 1978. Since then, ARCS Foundation Seattle has awarded $15.4 million to 1,114 aspiring scientists in the United States. So many of you have asked how to support ARCS Foundation that it might be useful to review the giving options. There are basically 4 opportunities. As you've already heard, corporate sponsorship is deeply appreciated. A second significant opportunity is to fund an endowment. I was prepared to announce that we have 2 matching endowments available. However, just prior to the luncheon, those 2 were scooped up. So we are delighted to announce the 2 new matching endowments: the Yvonne Piggott Endowment at the University of Washington, and that Locke Anderson and Alan Perkins are establishing their second endowment at Washington State University. That brings our total of endowments to 48. At $100,000 each, and the endowments support the ARCS Foundation Fellows into perpetuity, and it has built our fund to $9.1 million. Seated among you today are endowment donors who have created endowments in 2015. They are Alicia and Jeff Carnevale, who have given the UW ARCS Endowed Fellowship in Oceanography, the Doris Carnevale UW ARCS Endowed Fellowship in Nursing. There's the team. And the Sophia R. Carnevale ARCS Endowed Fellowship at WSU. Thank you to the Carnevales. And we have a second ARCS endowment from the Zevenbergens, who established the new Nancy and John Zevenbergen Jr. ARCS Endowment. Thank you for your investment in furthering Seattle's economy and the international impact that ARCS Fellows can have. Thank you. A third giving option is to give a fellowship. When you give a $17,500 fellowship, you can pay it over 3 years in which your fellow receives that gift. So it goes to him over 3 years, and you can pay it in 3 years. And also, 2 donors can give a fellowship together if you choose. Fellowships commencing right now for the next fall these are the most recent fellowship donors: Carol and Elias Alvord, their second; Patty and Jimmy Barrier in memory of Boss Barrier, their 5th; Zan Brookshire and Bert Green from the Brookshire Green Foundation, their 4th; Peter and Winky Hussey, this is their 2nd from the Hussey family; Nancy Mee and Dennis Evans have given their third. Joanne and Bruce Montgomery for Wiley S. Montgomery have given their 10th. Eleanor and Charles Nolan just gave us their 4th. Molly Pengra at Pengra Capital Management has given us her 6th. Sarah and Andrew Watts have added their names to the fellowship roster. Andrea and Eric Thorson and Tina and Carl Naders share a fellowship, and this is the 3rd year for the Thorsons and the 2nd for the Naders. Washington Research Foundation this year has given us their 96th, 97th, and 98th fellowship. Pretty amazing. And it was a wonderful surprise yesterday to hear from Washington State University that they have just given us a Graduate Dean Fellowship. Hot off the press. Thank you, Washington State. Thank you for supporting our fellows who draw grants to their schools and often stay in our area to do research. They are the petri dishes from whom startups grow. Thank you. And if you would like to spark Seattle's economic growth that is propelled by technological innovation and scientific exploration, you can exercise the 4th giving option. You could make a pledge today. You can check that option on the card that your table captain will give you later. An additional way you can help is to make a planned gift that will activate at the time that you designate, generally in a will. You can indicate your choice to create the discoveries of the future by checking that box also on the card. So after lunch, we'll give you a break. You do get to eat. Please welcome to the stage our Master of Ceremonies, Hanson Hossain. Hanson is Director of the Communication Leadership Graduate Program at the University of Washington and President of HRH Media Group. He also hosts 4 Peaks, the Telly Award-winning UWTV Current Affairs series, and is an Emmy Awards recipient. So we're very fortunate to have him as our MC today. Thank you, and he will do a great job of introducing our 4 fellows. So please enjoy finishing your conversations with the people at your table and welcome Hanson when he comes up next to join us on stage. Thank you.
Okay, we got 3. We got 1 more to go. I'm going to take your mic a bit. Good afternoon. As you were warned, I was meant to come up on stage about this time. My name is Hanson Hossein, and as you heard, I'm the director of the Communication Leadership Master's Program at the University of Washington. So I am not a scientist, but our 2 degrees that we have in our program are both STEM degrees. And I firmly believe that today, what we're living in right now is the communication age. Even as you're communicating with each other at your tables, you may have tried to sneak a look at your cell phones at the same time. So we're all communicating all the time. And I think that as we look at the proliferation of good innovation and science in our country, good communication is fundamental to that. And you're going to hear some remarkable communication from the scientists and scholars who are going to be on stage with us today. And so this is my 2nd year on stage, and it's absolutely fundamental that we continue to inspire younger generations around the work that these people are doing, which is why I agreed to come back a 2nd time. So today we honor 155 ARCS Foundation graduate students, and let's start with a video.
There are relatively few truly excellent potential graduate students in the country, and the competition for these graduate students is intense.
Our competition for recruiting are the very best schools in the nation. We're talking about Harvard, Stanford, Princeton, and so on.
Our students very often have offers from one or all of those schools.
For me, the ARCS Fellowship was the sort of deciding factor. It was the tipping point.
It was the real decision maker for me as far as deciding to come to Washington State University.
The ARCS recognition was, to me, considered an honor.
The ARCS Fellowship, to me, is being able to send my daughter to a great school.
The ARCS Fellowship gave me both the incentive to come here as well as the freedom once I got here to explore whatever research direction I wanted to go.
When I hear about the work that our ARCS Fellows are doing and how excited they are in making a new discovery, it really brings me back to when I was a young scientist and was for the first time making a discovery.
There's really nothing like having one of those aha moments in research.
I sort of have an aha moment every day.
Right now, you know something that no one else has ever known before. That's really a fun moment.
You know, you feel ecstatic and you just want to go find your colleagues and share with what you found.
When I see someone have one of those great aha moments, I remember how hard they worked to get to that point.
I take vicarious joy in seeing young scholars have breakthroughs in their research that changes the direction of science.
It's really exciting to be a professor working with these kinds of students. That's why most of us choose academia, to work with the very smartest young people.
These are people that really feel they can change the world through scientific discovery.
What I really like about my research is the ability to extract meaning from all this data and really seeing which components are moving and evolving in space and time.
The human impact of my research is it may allow farmers in the area to have higher yields with reduced inputs of pesticides.
Use the knowledge that I've gained here to apply to helping us grow more food.
There are people who don't have the capacity to fight for themselves and their right for health care, and we can do that as academics.
My current research focuses on the rehabilitative aspects of brain-computer interfaces to help with stroke patients or spinal cord injury patients.
My research is focused on developing a therapeutic for celiac disease. My dream is that this therapeutic will be available for people with celiac disease to take.
When I started my PhD project, there were essentially no known genetic causes for schizophrenia. And by the end of my PhD research, we
really began to unravel the causes of, for a lot of people, schizophrenia.
The ARCS fellows we have in the Paul G. Allen School for Global Animal Health focus their research on how to prevent or control infectious diseases.
So my research focuses on relapsing fever, which is a disease that affects people worldwide, but most significantly people in Africa.
We're doing stuff that hasn't been done before.
I want everybody to know that ARCS isn't just about giving students money, but it's also about providing a network.
One of the things that's been fascinating for me to watch over the years with the ARCS fellows is the relationships they develop with the donors and lifelong friendships.
It's also just nice to know that we have a group of people who support us, not just our program, but really a whole foundation of people.
And that's been a great motivator to keep going with my research, knowing that people outside my lab, my building, my department really do care about what I'm working on.
You know, these ARCS scholars that come to the university, these will be the future leaders in how society tackles our largest scientific and technological issues that face us all. These are the people that are our future.
So the scientists who appeared, thank you. Your applause is well merited. The scientists who appeared in that video are real stars, and many of them are here today, so perhaps we can recognize them in person. If you'd like to stand up, if you were in that video, please. So today we honor ARCS Foundation Fellows from Washington State University and the University of Washington. First, I'd like to have all first years stand, please. All first year fellows. The ARCS Foundation Fellowships made a huge difference in attracting these students to Washington. Their research is really about to bring some truly dramatic discoveries to our world, and we're fortunate enough to be here now at the beginning of their epic stories. And so please remain standing as we applaud the unbelievable array of interests, achievements, distinctions, and accomplishments that define this outstanding class of 2015. So to join our first years, and I'd like to ask our second year class to please join and stand. Second year fellows, please. And now our third year scholars, please join our first and second years, third years. These remarkable young scientists in the STEM fields of science, technology, engineering, and math are powering the engines of innovation that will change our world. Thank you very much, and please be seated. So now on stage, we have 4 ARCS Foundation Fellows who have joined us. And I mentioned earlier how crucial communication really is to the proliferation and advancement of science in this age. And I've found that these 4 scholars are actually quite terrific communicators who represent a variety of interests and disciplines. So they're all going to tell you about their work and what kind of contribution the ARCS Foundation has made to their success. So please welcome, and we're starting from left, well, your left to right. Elena Skornikov, Washington State University, Integrative Physiology and Neuroscience. Corey Brownstein, Washington State University, Molecular Plant Sciences. Julieta Grusco, University of Washington, Physics. And Aaron Garcia, University of Washington, Neuroscience and Behavior. And we're going to hear first from Elena from Washington State University. Elena.
Hi, my name is Elena. I was born in Kiev, Ukraine, but grew up in Spokane, Washington. I received my bachelor's from Eastern Washington University in 2010 and a doctorate in physical therapy, also from Eastern Washington University in 2013. I am now a third-year student in WSU's Neuroscience PhD program. My first year of research focused on how forward head posture alters neck muscle activity. The prevalence of one-year neck pain has been reported to be up to 75%, and several studies have showed that those with neck pain tend to have greater forward head postures. Forward head posture is also associated with headaches, shoulder problems, and TMJ or jaw joint problems. And it's especially prevalent in today's society where the use of cell phones, smartphones, and computers are so extensive. Forward head posture is a problem because, well, in a normal posture, your head sits relatively right on top of the rest of your body. So in a sense, your body is holding up your head. But with forward head posture, your body no longer supports your head. So gravity is going to want to pull your head down. The muscles on the back of your neck have to work a lot harder to avoid the effect of gravity trying to pull your head down. Some of my research involved using electromyography to determine which muscles are more active in forward head posture and other abnormal postures so that providers would know which muscles to gear therapeutic interventions towards. Most of my time at WSU, however, was spent at the Sleep and Performance Research Center studying sleep. Our sleep lab is one of the few labs in the world where we can have subjects come in and literally live in the lab for several days or even weeks at a time in a completely controlled environment. That means no cell phones, no internet, no windows, but rather completely isolated from the outside world. Most recently, I've been looking at the effect of shift work on sleep and on performance. In the meantime, we had a baby girl. She is now 1.5. So we're enjoying chasing her around the house. And we're also very excited to know that we have another little one on the way. Thank you all for your support. Thank you to my donor, Jeannie Nordstrom. The ARCS Fellowship has made a huge difference in my life. And I say that not only as a graduate researcher, but also as a student and as a new mom. Thank you for making this all possible.
Elena, thanks. Hold your applause. I'm going to ask a follow-up question. But Elena, thanks for that. As you heard from the audience, they were responding to your amazing isolation as you're testing people on sleep. And I think I saw some people straightening up when she was talking about posture. So I have to ask you, do you practice what you teach when it comes to sleep and to posture?
Well, I don't sleep for 8 hours a night, but whenever I think about it, I do the exercise that I tell my patients with forward head posture to do, and that's to sit up nice and tall, relax your shoulders, so don't shrug your shoulders. Now bring your chin directly back. So in a sense, you're trying to create a double chin. Hold that for 10 seconds, okay? And then relax, but try to hold that posture. Now do that 5 times a day.
I don't think I'll be doing a double chin thing in public. Thank you very much, Elena. Corey Brownstein, Washington State. Oh, you guys, yes, thank you. Thanks for that. So Corey Brownstein from Washington State University as well, who just has remarkable posture, what I could tell. So Corey, go ahead.
My name is Corey Brownstein. I am a third-year ARCS Fellow and fourth-year PhD student in the Molecular Plant Sciences program at Washington State University. More specifically, I am researching the use of medicinal plants and their chemical composition under the supervision of Dr. David Gang. In 2011, I received my undergraduate degree in plant biology from the University of Missouri and remained there to begin my PhD. At the end of my first year, I transferred to Washington State University because of its research capabilities. After the Dietary Supplement Health and Education Act, or DSHEA of 1994, herbal supplement companies began marketing products regardless of their safety and effectiveness. DSHEA states that medicinal plants do not have to be approved by the FDA. This is a problem because the claimed benefits of a product may not have enough evidence to support that claim. At WSU, I am researching a rare medicinal plant, devil's claw, which is native to southern Africa. The roots of this plant are widely used in Europe, South Africa, and to some extent the United States to treat osteoarthritis and lower back pain. Human clinical trials have shown that this plant has anti-inflammatory properties. Due to the demand for its medicinal properties, it has become endangered because cultivation is limited, it grows slow, and has about a 1% seed germination rate. Thus, finding an alternative plant is a must. At Washington State University, I have identified a few medicinal plants that are native to the United States that produce some of the same active iridoid glycosides found in devil's claw. These plants, Scrophularia, had been used by Native Americans to relieve pain and inflammation. A paper from 1849 even mentioned that Scrophularia were a woman's best friend. In collaboration with Vietnamese scientists, I am also analyzing the chemical composition of Vietnamese plants. Several of these Vietnamese plants produce some of the same compounds found in devil's claw. These compounds are in low abundance. However, I was able to detect them for the first time using the sensitive LC, or liquid chromatography, mass specs at WSU. I am the only person in the US researching these Vietnamese plants and Scrophularia. I have been able to detect thousands of compounds and determine which of these are shared between the Vietnamese plants, Scrophularia, and devil's claw. Without the mass specs at WSU, the sensitive mass specs at WSU, this would not have been possible. In my spare time, I'm also developing a website, natureclaim.com, because the internet lacks honest and unbiased information about natural products and their claimed benefits. The ARCS Fellowship enabled me to make the move to WSU more easily and to promote the research capabilities of WSU to Vietnamese scientists. I would like to now thank my donors, Andrea and Eric Thorson, Howard Wright, and Kate Janeway, and the ARCS community. Thank you again.
And just in case you're wondering, there is no teleprompter up here. These guys are speaking this well on their own, really well. So Corey, what's it like to be an American scientist in Vietnam? That's amazing that you've been doing all that work there.
So they had a painful history, but they're so welcoming to us and scientists and even tourists. And so working with the Vietnamese, they basically are saying, we have these plants here. We want people to understand and figure out why do these plants have these particular medicinal properties. And so I basically tell them, I said, we have these instruments at WSU that can basically look at these molecules and determine the activity, potentially what gives these plants their medicinal properties. And since I am at WSU, and when I first came here to WSU, basically WSU was the only school that had these instruments to use to research plants. And so basically telling Vietnamese, you have the plants, I have the instrument, we can work together.
Great, thanks very much, Corey. So from posture and back pain, we're going to cross the mountains from WSU to the University of Washington and hear from Julieta Grusco, University of Washington.
Hi, I'm Julieta. I'm a fourth-year PhD student in physics at University of Washington. People often ask me how I decided to go be a physicist. It's kind of an obscure field, but what I think is more interesting than how I became interested in physics is how I had the opportunity to turn that into a career, and I think the key word there is opportunity. I'm really aware of this because I was born in Argentina and I grew up in the United States, and if my family had stayed in Argentina, my interest in math and science would have translated into a job as a doctor or an engineer, something where you can clearly see kind of what comes after you study, not working on discoveries. It's because of the support of research and the way that universities work in this country, putting students in direct contact with cutting-edge research, that I decided to be a physicist. And organizations like the ARCS Foundation are a huge part of that, so thank you all for that. My research in particular focused on a particle called the neutrino. Neutrinos are these very light, neutral particles, and we don't really know much about them. They've kind of confounded our expectations at every turn. Every time we do an experiment, we see something we didn't expect. And so with normal matter, there's matter and antimatter. You might remember that from a Dan Brown novel, maybe. And normally, if you combine one particle of matter and one particle of antimatter, they can cancel each other out, or what we call annihilate. But if you have two particles of matter or two particles of antimatter, you just have two particles. Nothing happens. But with the neutrino, there's a possibility that this process could actually happen, that you could combine two neutrinos and have them cancel each other out. This is really interesting for us because we don't know why, after the Big Bang, there was more matter left over than antimatter. Our current theories tell us that there should have been equal amounts of both, and they should have canceled each other out. So why does the world have so much stuff in it? And that's kind of the question we want to answer. This is a really hard question to answer. It's a very faint signal we're looking for. And that means that we have to do things like electroform our own copper underground and house the experiment in what used to be a gold mine in South Dakota, a mile underground. So there's a lot of technical challenges. The technology we use is a semiconductor detector, which is a lot like what's in your computers. And if you've ever wondered how we make sure that Iran is fulfilling its commitments to our recent nuclear deal, or how the Department of Homeland Security scans containers coming in at ports, the answer is a detector like the ones I work on developing. So there's a lot of applications for this kind of technology. I'm so grateful to the ARCS Foundation for bringing me here to University of Washington. It was one of the major reasons that I decided to come here. Part of it was that it got me into the lab early on, which is so important for starting your career. But also, there's just a way in which your support is the first step of a long career. It's the first vote of confidence in us as researchers, and other organizations and people pick up on that, and it really changes the whole trajectory of our career paths. So thank you to the ARCS Foundation and to my donors, Linda and Tony Watley, for giving me that opportunity. It's been amazing. Thank you.
Thanks very much, Julietta. That gold mine in South Dakota sounds like part of that Dan Brown novel. So how on earth did you figure out that a gold mine in South Dakota is going to be perfect for your research?
So this mine in particular actually has a history of having science research done there. The Nobel Prize-winning first detection of neutrinos from the sun was actually done there while it was still an operational mine. Now it's been closed down, but it's just amazing watching what used to be a town that revolved around the gold mine turn into a town that's kind of revolving around science that's happening there. And the people there have been incredibly welcoming, and they're very excited about this new economic engine in their town. So, that really is very inspiring.
That's great. Thank you very much. That's Julietta Grisco. Thank you for sharing your work. And finally, we're going to hear from Aaron Garcia from the University of Washington. Aaron.
My name is Aaron Garcia. I'm a fourth-year graduate student in the neuroscience program at the University of Washington. And I'm a Midwestern transplant. I was born and raised in Michigan. I graduated from the University of Michigan. And that's where I first really got interested in neuroscience research. So I worked in a lab out there that was studying the neural circuits underlying the reward and motivation to pursue natural reinforcers, so things like food. And I thought that work was very interesting, and it played into another interest of mine, which is what happens when reward and motivation reaches pathological levels for unnatural reinforcers, so things like drugs of abuse. And drug addiction is a huge health issue and socioeconomic issue. The National Institute of Drug Abuse estimates that illegal drug use costs the United States about $193 billion annually, not to mention the great personal and emotional toll it takes on people. And drug addiction can really affect anyone. I mean, I think about the recent death of Philip Seymour Hoffman, who passed away last year. And obviously a very successful Oscar-winning actor, 3 children, had been sober for 23 years, and then suddenly at the age of 46 relapses and dies of a heroin overdose. And I bring this up because I think it really highlights 2 of the main characteristics of drug addiction that make it such a serious issue. One, it's a persistent problem. Even after an addict reaches sobriety, there's this lingering possibility of relapse and craving that will really follow them for the rest of their lives. And 2, drug addiction really does affect anyone and everyone. I mean, it spans across different age groups and different socioeconomic classes. And I'm sure that there are many of us in this room who know somebody who's been affected in some way by drug addiction. I know personally, in my own family, on both sides of my family, has been affected by drug and alcohol abuse. And that's been one of the major motivating factors for me in pursuing this line of research in graduate school. And so in my lab at the Seattle Children's Research Institute, just down the street, we're interested in what's happening in the brain during that transition to addiction. So with the idea being that there are many people who try drugs recreationally, but there's a subpopulation of people who are especially vulnerable for the recreational use to transition to addiction. And it's the addicts who are causing the majority of the damage to our society. So the way we study this is I use an animal model in which rats are allowed to self-administer cocaine, so they can take as much as they want, but they're forced to do so in an intermittent pattern. So they have a period where they can take the drug and then an extended period where they're not allowed to have drug. And that's in contrast to most of the studies that have been done in which the animals are allowed to continuously take cocaine. And the reason we do that is because it seems like the intermittent paradigm actually better mimics what human addicts go through. So a human addict will take a big dose of cocaine and then they won't take any more drug for at least an hour or so. And if you ask them why, they'll tell you that, well, it would be a waste of drug if I took it beforehand or took any more after. So they really let themselves get high and then fall back down before they get high again. And so the intermittent paradigm forces the animal to experience that same spiking blood cocaine levels that human addicts experience. And if you do this model, you find that the animals have a higher motivation to take drug. And I've also found that it changes the activity pattern in certain cells in the brain. And so what we're interested in is if we can use new technologies to actually control those cells and try to manipulate them to try to reduce that pathological motivation to take drug. And hopefully one day we'll identify a therapeutic target. And so with that, I would like to thank everyone from the ARCS Foundation for all of their generosity and support. I can say that it was one of the major motivating factors for me in choosing to attend the University of Washington. And it's been a wonderful thing to have and has really helped me with my own research. So thank you.
Thanks very much, Aaron. So Aaron, this is clearly very profound work. As you're looking at addiction and the cellular and circuitry part of the brain, is there a chance that if you're successful, there might be a pill one day for this kind of addiction?
Well, that's a great question. And obviously one of the benefits of doing animal research is we can do some more invasive techniques with them. But obviously, before we ever transition to humans, you want to be as non-invasive as possible. Fortunately, there is progress being made in the field with controlling cells via systemic means. So hopefully one day we will have a non-invasive answer.
Thanks very much, Aaron. Thank you, Aaron, and thank you to our 4 remarkable scholars who are doing incredible work in science. Thanks very much. So I'd like to now introduce my colleague from the University of Washington, Dr. Ginger Armbrust. She's the director of the UW School of Oceanography, and she's exactly what my 7-year-old daughter wants to be when she grows up, a marine microbiologist and professor of oceanography. Dr. Armbrust is also head of University of Washington Center for Environmental Genomics. You already seen her in the video, and because she clearly supports the ARCS Foundation, it's perfectly natural that she comes up here to address you all. So Dr. Armbrust.
Thank you very much for the introduction, and thank you all for having me here today. I can't tell you what an honor it is to be here. I so admire the work you do. It's remarkable how your dedication and your generosity and your commitment to bringing in this next generation of scientists, I can't tell you how much I admire it, so thank you very much. So, I graduated from Stanford University, and at the end of my undergraduate, because of a number of twists and turns, I was able to participate in a research expedition to the middle of the Pacific Ocean, and I fell in love with it. I loved the adventure of being at sea, and I loved the big questions that I could ask about how the Earth system works and the roles that the ocean play in regulating the health of our planet. Now, fast forward a few years, and as they said, I'm the head of the School of Oceanography at UW. And one of the really fun things that I get to do is at the end of graduate student recruitment period, this very intensive 2 days where we're trying to recruit the best and the brightest to our school, I'm the one that gets to tell this very small subset of students that we would like to offer you an ARCS fellowship. Now imagine how much fun that is. I get to watch first the surprise that goes across these students. Then, as I tell them more about what an ARCS fellowship, how we chose them, I start to see the pride that comes. And then there's this moment where you can see them doing the internal calculation in their head. And they're saying, oh, that's going to make a real difference to me, right? And it does make a difference to them. We're recruiting students from across the country. It allows these students to come to the University of Washington, where I am, but to our region, and they still have enough money to go visit their family. So this is a wonderful undertaking. So what happens once we're able to bring these great students to the university? Well, you've all gotten to hear that these 4 that we heard, and I hope you've been able to talk to students at your table. Imagine working with them on a daily basis. They keep you on your toes. They make all the faculty better. They are inspirations for the undergraduates in our program. The undergraduates get to see that you can be smart and cool at the same time, and that's really important to these students as they start to progress through their careers. So I like to believe, and I think we all would agree, that your work through the ARCS Foundation helps us recruit these wonderful students to the universities, and they become part of this very important enterprise, this ecosystem. And you know, at University of Washington, we're all now reveling in the latest ranking that said the University of Washington is the top-ranked public university for innovation in the world. Okay? Yeah. Now, you may not know this other fun fact, but we're reveling of it in oceanography, is that the latest rankings place environmental sciences, earth sciences at the University of Washington within the top 10 in the world, and we are only bested by 2 other academic institutions. So part of what we're doing with bringing in these fabulous students into our program has to do with this kind of creating this innovative ecosystem. So I'm going to end with one story that I'd like to tell you about the direct impact that the ARCS Foundation has had on our program. So in 2005, there was a student, a very talented young man that graduated from the University of California, San Diego. He was recruited to the physics department here, we just heard about. He was recruited to the physics department for his PhD with an ARCS fellowship. He then did wonderful work. He then finished his PhD, was recruited to go do postdoctoral research at MIT. He was one of the top-ranked people in the country, recruited to MIT to continue his postdoctoral research. A couple of years later, he was on the job market for an assistant professorship. And we were in, the School of Oceanography was in competition between MIT and Cal Berkeley for recruiting this very talented young man as an assistant professor. Well, guess who won? The University of Washington was able to bring him back to the university as an assistant professor. Why? Because of the innovation that happens here in our region, but also because he fell in love with the university when he was recruited here as an ARCS fellow. So from the bottom of my heart, thank you for helping us recruit this great guy back to the university, who I know will continue to make a huge impact on students for generations to come. So what I'd like to do now is to ask you all to continue with your generosity, continue with your commitment to helping foster this next generation of students. So there are envelopes, I believe, at each of your tables that can be used for your donations. There are table captains that will help you if you have questions, and will collect this. And so thank you so much for your generosity here. It really makes a difference.
Thank you so much, Ginger. We really appreciate your comments, and thank you, Hanson, for your help as well. So if you could pass your envelopes around, there are cards there for you to take, and take a pen too. There's a wonderful ARCS pen in the packet as well. So you know that the centerpieces we can't take home, so you might as well look under your cup, under the saucer under the cup, and see whether or not you have a sticker, an orange one that will tell you that you get to take the centerpiece home. So if I could just have your attention for one more minute, we're ready to go. Thank you for joining us today to discover the impact that ARCS Foundation Fellows can indeed deliver. You are showing your gratitude to the scholars who are influencing the biotech community we live in through your generosity. When you join us again next year, we hope, we will show you how well your investment is working, so come back. It has been my pleasure to spend this hour with you, and I look forward to seeing you next year. Thank you for your time and your interest. Thank you. We're ahead of time.